In this video I'm going to be going through some Truss questions from Engineering Mechanics by Arnie Haj, the guy who does Eureka Engineering. I'm going through questions 19 and 20. I'll probably do 20 as a separate video. That he solves these questions using the method of joints. I'm going to be using the method of sections. What I think is interesting as I'm getting to the reactions is we have this force here, 230. So Copeland, he would say that we have 5 steps to finding reactions. The first step is to draw a free body diagram. That's already done for us. The second step is to convert this force into its components. So I've already done that here. That breaks down into this and this, 115 and 19.2. I have to calculate that distance. I'm probably going to have to calculate that distance anyway, but so that's taken me 2 lots of trigonometry to find that, whereas we can see that it wasn't actually necessary because when we go here, we're going to get 0 equals 0. We've got clockwise 115 times 1 meter, and then we've got anti-clockwise 199 times 0.577. What we find is that when we multiply those numbers out, we'll get 115 for both, and that's going to cancel out. So it's the same as if we took 230. That's it. Because 230, this has got this has got no perpendicular distance. It's the same effect. So what our answer is going to be is we're going to get 2RC equals 230, because no other forces on there. So RC equals 115, which is what we got there. Okay, this is all measured in newtons. Oh, that's here. Oops. Okay, once we've found that, how do we find RAV?
The same way.
Sorry?
The same way.
We could find RAV by taking moments about C. That's possible, but it's a lot faster for us to instead say we're going to find RAV using the sum of the forces vertically. Now, as you may know, I like to draw that as, and this is where the Copeland method is useful, in that I need to know these vertical forces anyway to be able to use that method. Yeah? To be able to use that method, I need to have the component. So I need to know that I've got the vertical component of that 230, which is 115, and I've got 230, and I've got 115, which is our RC. Is there any other vertical forces? I can see 1 vertical force, 2 vertical forces, 3 and 4, that's it. So this one here is going to have to be RAV equals 230 up. Yep, okay, that's good, and that's right. Okay, so we're moving along. 230. I'm going to clear this off. So, the next thing we want to do is we're going to start solving this truss. So we will start off with AB. When I'm looking at which section I'm going to cut, there's my cutting plane. I can either take this side or this side. There's no way that I can avoid reactions. So, I mean, I could do something like that, but that's a bit of a complicated one. So just to point out that I could cut through the top. If I cut through the top like that, how does that work for me? Well, the problem is with this that I can't find RAB I can't use this one effectively, this cutting line. And the reason why I can't use this cutting line effectively is because I can't eliminate these 2 unknowns by using the Meetup method. Because if I use the Meetup method, it's also going to eliminate this And if I eliminate everything, then I don't get an answer. That's not helpful. I also can't use the lone wolf method because there's not one of these three sections has something that is unique. So there's nothing that only, well, this one here takes 0 horizontal, but there's nothing that's going to help us to solve that question. So that's why we're going to cut it this way, and the answer, what we're going to look at is we're going to look at that. I don't like that it means looking at two forces, but it's better than nothing. Now, what I can see here is we want to find AB. We're assuming tension, so we're drawing the arrows out because we're assuming tension. Now, what can we do? What do we know about AB? We can find a point that we can eliminate B. So we could take moments about D, for instance. So that's all that. We could take moments about D, and that would eliminate AD. That's one method we could use to find AB. But there's an easier method. What method is that? Lone wolf. Because AB, I think where possible, we prefer to use lone wolf. So we can say the sum of the forces vertically equals 0. And what we know is that there is 230 going up. So that means there has to be 230 going down. AB is the only place where that can happen. Because we can see that it must be going down, we can say AB must be in compression by observation. Because this is going down and this is going up, that means it's not tension, yeah? And if we know this size, well, this is a 30-degree triangle. We've said before that the long side of a 30-degree triangle is always double the short side. So what's this value going to be? It's going to have to be 460, right? Because it's twice the value. So it gives us 460 in compression. So just to be clear here, what's going on here? This is AC vertical. I'm just going to draw that out again. We know that AC is going to be looking something like this. This is AC vertical. This is AC horizontal. We need to be able to figure out what is the value of AC proper. If we know that AC vertical equals 230, well, this is going to be bigger than that, right? It's going to be just to prove it. I mean, I like to memorize the values, but there we go, it gives us 460. And we've established its compression from observation. So that one is correct. Okay, the next one we're going to look at is AD. Now, we could use that same cut. If we use that same cutting plane, we have AD here. Well, we can't use a lone wolf method there. What we can do is we can use a meetup method where we choose a spot that AB passes through and then take moments about that. Right? So what's a point that AB passes through that AD doesn't? Well, if we look at AB passes through here, if we choose A, that's no good because AD passes through it as well. To use the meetup method, what we have to do is we have to say, hey, AB, I want you to go, Alison Bree, I want you to go meet up with my friend and I want her to go somewhere else away, and then we're going to measure the meetup by making this one meet up. Now normally we get both of them to meet up, but in this case it's only one to meet up. So we're going to say, hey AB, why don't you go up to A, and if we measure from A we can use this equation, right? So let's have a look. Sum of the moments measured from B equals 0. So we're measuring from B. What that means is that AB multiplies by 0 and it gets eliminated. Or it can be ignored in this question. The next force that we have to look at is, if we're going clockwise, we'll say AD. AD is how far away from point B. How far away is it from point B? We've already found this size. I've already found that size earlier. It's 0.577. Is it going, if we're assuming that it's in, is it going clockwise or anti-clockwise? Anti-clockwise. Okay, so I found 0.77 here. I found that earlier. Okay, and then we're going to do this force here, 199. What perpendicular distance is it to be? What's its perpendicular distance to be?
1 meter.
So it's here, it's running through that point. What's its perpendicular distance to be?
1 meter.
So it's running like this. Where is it closest? It's closest here. What's that distance? 0.577, that's right. Okay, and lastly we have 230. Is 230, is it going clockwise or anti-clockwise relative to B? Clockwise, so it's going to be plus 230. What's its distance? So if I extend this force up forever, right, and I run along, where is it closest? It's closest here. So its perpendicular distance is that distance. What is that distance? One meter. Do you see that? Yeah? Do you see how if we run that along forever, it passes through this point, its perpendicular distance there is 1 meter. Yeah? Okay, so let's have a look at that. What we can do straight away is we can bring that over here, we can add that to both sides. 0.577 AD equals, and then I've got okay. And we've got that. Now, our answer is positive. Yeah, so our answer is positive. We made an assumption here. We said assume tension. Answer is positive. Therefore tension. Okay. We've now found AD. The next one that we're going to look at is a BD. BD is this line here. First of all, we should ask, is it a zero force member? Okay, I've got some students saying yes. The thing is, if it looked like this, in that case, it would be a zero force member. But it's not. How do I know it's not? Because this force is being applied to it. Now, in that situation, let's get the magnifying glass out. Bring that over here. Okay, I've got some members here. Let's label them. I've got BD, I've got AD, and I've got CD. Can it take vertical force? AD. It's a horizontal line. Can't take vertical force. Can CD take vertical force? No. So if we use the sum of the forces vertically, okay, if we say sum of the forces vertically equals 0, 0 equal, well, I can just draw, I've got 230 going down, so therefore I must have BD. Now if it's going up, is it pulling out of the node, or is it pushing into the node? It's pulling out. And what did we say if you're pulling out? It's tension. Okay, so BD is going to be 230 in tension. So we could say that BD equals 230 in tension. And we can just say, we're allowed to say just by observation. Yeah, we could write some of the forces equals 0. We could do all that, but we don't really need to. We can just say, in this situation, it also means that if we know AD, if we know that AD is in tension, so we know that AD is in tension. Remember how we draw tension? Right, we draw tension like that. That makes a C. That looks like a T in tree in Japanese. Yep. Okay. So if that's in tension, that means both sides look like that. That means that if I draw just half of it, it's going to be pulling out. Which means that this side has to be going that way to balance it. Which means that CD is going to be the same. CD is going to equal AD. And I'm allowed to write that just because it's faster. And I can say, again, that's just by observation. So we've only got one force left. DCCD. Which is BC. So we're going to take a similar approach to the way we did the other one. We're just going to take a section, and this time we're going to take this side. Oh, sorry, whoops, I've said this is 115 newtons. So if we use our lone wolf method, what we can say is assume BC and CD. We can say here that the lone wolf will tell us that sum of the forces vertically equals 0. So if we have 115 up, then BC vertical, the vertical component of BC is going to have to be down. And so that means BC is going to be that. Can you tell me how big is BC going to be in that case? Sine of 30 is a half, so it's going to be divided by a half, that's going to be twice as big. So BC is going to equal 230. It's going down. If it's going down, is it into the node or out of the node? Into the node, so that means it's going to be compression. Okay, we're done. Okay, now we've got question 20.
What you gonna say you're gonna do this on a separate video?
Yeah, I did say I was going to do that as a separate video.